Hello, Luke. Welcome to lesson 102. So today we'll be talking about absolute value inequalities. So as a quick startup here, let's begin with talking about absolute value. So a quick review. What is absolute value? Remember, we denote it with these bars, right? So if I have the absolute value of a negative 2, for example, what is that? What does that mean? Well, you may recall that the absolute value of a negative 2 is what? 2, right? And the absolute value of, say, a 3 is actually a 3. And the absolute value of a negative x is what? An x, right? So the absolute value, you might be tempted to think, is a way of removing the negative sign, right? We have this negative 2, we take the absolute value of it, it becomes a positive 2. And if it's a positive already, well, then we just leave it positive. Okay, that's one way that you might be tempted to think of it, but it's a little bit inaccurate to think of it that way. You're not really getting the full picture when you think of it that way. And there are a number of different ways that you can kind of describe what the absolute value actually is. One of the best ways that I think, anyway, to describe it is to think of the number line. So if we think of the number line, let's pull that up here. And we look at this number line, and if I want to find, let's pick a point on here. Let's say I want to find the absolute value of, I don't know, let's pick a negative 4. All right, so absolute value of a negative 4. All right, I'm just picking that. What does that mean? Well, what we're actually looking for is kind of the magnitude of the number, or kind of how far away from 0 it is. So if we think of 0, this spot right here, as being kind of the origin, kind of the center, the beginning of the number line, and then the number line extends out to the right forever in this direction, and then it extends out to the left forever in this direction. But the beginning point is really this 0 point right here. Okay, the absolute value is kind of the distance away from the 0 that a number is. Okay, so if we think of the negative 4, we might ask, well, what's the distance away from 0? And if we count up, the number line segments here, we have 1, 2, 3, and 4. It's 4 units away from 0. So the absolute value of 4, or I'm sorry, the absolute value of negative 4 is 4. And I didn't really just turn it into a positive 4. I'm really just counting the units that negative 4 is away from the 0. It's 4 units away from the 0. All right. And if I were to take the absolute value of a positive 4, well, that puts me out here. And again, I'm not just saying, oh, well, it's positive 4. I'm actually taking a little bit more of a couple of steps here. I'm really just making it a little bit more rigid here. What is the 4? It's 4 units away from the 0, right? It's 4 units away. So the absolute value of 4 is 4. Okay? So that's one way to think of the absolute value of a number. Its distance away in terms of how many units away from 0 it is. Okay, so with that in mind, let's embark on a few problems here. So let's say I have an unknown, an absolute value of some unknown number, and I want to solve this inequality. So I'm asking, what numbers could I substitute in for x such that their absolute value would be greater than 3? Okay, and that might sound a little confusing at first because we have absolute values, we have greater than, we have an inequality right here, and it's kind of sometimes hard to wrap our minds around what we're really looking for. But if you think of it in terms of what we've just described, you might ask yourself, okay, well, what numbers are greater than 3 units away from 0, right? Because the absolute value is the number of units away from 0. So what numbers are greater than 3 units away from 0? And the best way to picture that is to throw our number line out here again. So if we look at our number line, And if we find that, that 0 mark right here, and we say, okay, this is, the beginning of the number line, and I'm asking what numbers, I should say the absolute value of what numbers is greater than 3. So in other words, what numbers are more than 3 units away? Well, there's going to be 2 areas that would prove to be true. So we could have, 1 unit, 2 unit, 3 unit. So really anything over here, anything on this line over here would satisfy the inequality, right? From this 3 onward. Now I might actually say I can't have it a 3. So I'll put let's actually make this a little cleaner here. We'll put a hollow circle on this 3, and then we'll say anything over here, anything on the number line over here would satisfy the inequality, right? Why? Because everything on this red line right here, the absolute value of anything on this red line is going to be greater than 3, because it's going to be greater than 3 units away from the 0. Okay? But that's only half the story. The other half of the story is, well, we could go to this 3 over here. This is also 3 units away from 0. So I could say anything past this point would also satisfy the equation or the inequality, right? And if you're unsure, just take a couple of points and plug it in. So if I just pull out this -5, for example, say, okay, let's just pull him out, -5. If I substitute that in for the x, is the absolute value of a -5 greater than 3? Well, sure, because the absolute value of a -5 is equal to a 5. It's 5 units away from 0, which is greater than 3. And if I pull out a number from over here, let's say I pull a 7 out, the absolute value of a 7 is obviously greater than 3, because the absolute value of 7 is just 7, and 7 is greater than 3. Okay? But anything in here, within this range from -3 all the way to 3, anything in there would not satisfy this inequality. And to show that, let's just say I pick the number 2, for example. If I were to plug that in, I would have the absolute value of a -2 greater than 3. Well, the absolute value of a -2, that's just a 2. And a 2 is not greater than 3. So this is not true. Okay, so anything, again, within this range, from this hollow circle all the way to the other hollow circle, from -3 up to 3, that area is not going to satisfy this inequality. And the easiest way to think of that, again, is just to recognize that they're asking for all the numbers whose absolute value are more than 3 units away. So what numbers are more than 3 units away from 0? And then it's pretty simple. We just find the position that's 3 units away from 0, and everything to the left of that position will work. And then the other position that's 3 units away from 0, and everything to the right of that will work. Okay, so hopefully I'm being clear here, and that makes sense. Let's try another one here. So if we have the absolute value of x is less than or equal to a 2. All right, well, let's start by throwing our number line out here. And we're looking for all the numbers who are less than or equal to 2 units away from 0. All right, so here's our 0. So where would we be 2 units or less than 2 units away from 0? Well, if I go to the positive side, I would say, okay, well, this would be 2 units away. And since it could be 2 units, it's also less than or equal to 2. So in this case, 2 is acceptable. So it's a solid dot here. So this would be 2 units away from 0. And I want anything less than or equal to that. So anything less than that all the way down to my 0, right? This would be 1 unit away. If I come in here, this would be, a half a unit away, so on and so forth. So this blue segment here, those would all represent real numbers that are less than or equal to 2. Or I should say whose absolute value is less than or equal to 2. All right? But that's just one side of our origin, our 0. The other side is over here. So we have a -2 here. Well, that's also 2 units away from 0. So that would also satisfy this inequality. All right? And in like manner, anything to the right of that is going to be 2 or fewer units away from 0. So how would I graph this inequality right here? I would graph it just like this blue line is. I'd have a solid dot on the -2, a solid dot on the 2, and then a line that connects those two, showing all the real numbers that fall in this range are going to be acceptable for this inequality. And again, if you want to just check yourself, just pick a number. Let's pick the -3 outside of that domain, you might say, outside of that range of numbers that are acceptable. If I take that -3 and plug it in, what happens? -3, the absolute value of -3 is a 3, is a 3, and 3 is not less than or equal to a 2. That is not correct, right? So not correct. So obviously the 3 does not work. If I choose, or I should say the -3, if I choose a 4, for example, the same thing will happen. The absolute value of 4, is that less than or equal to 2? Well, no. The absolute value of 4 is 4, which is not less than or equal to 2. All right? So these areas do not work. The blue area does. Okay? Excellent. Let's move on. So let's try this one. This one is an interesting one. We draw our number line here again. The absolute value of x is less than a -2. Now, let's think about this for a second. What are we saying? We're saying we're looking for all the numbers who are less than -2 units away from 0. Does that even make sense? Could it be less than -2 units away from 0? That doesn't really make sense. So actually, this inequality doesn't make sense. What we're asking for is, what number can I plug in for x such that once I remove the absolute value bracket or braces, or I should say bars there, I'm going to have a number that's less than a -2. That's impossible, right? Because anytime you have the absolute value of anything, if it's a positive x, the absolute value is going to be an x. If it's a negative x, well, then the absolute value is going to be an x still. You always end up with a positive answer to an absolute value. So no matter what I plug in for x here, I'm always going to get a positive answer, and a positive answer is always going to be greater than a -2, because a -2 is negative, right? So I will never be able to find something that's less than a -2. So hopefully that makes sense. Therefore, this inequality, the solution is no solution, the null set. And that's what we could write for our solution. There is no solution to this. Anytime you have an absolute value of something and you set that less than a negative number, there's no solution. It can't happen. Okay? All right, let's try another one. How about this one? It's similar to the other one. The absolute value of x is greater than a -3. So the only difference here is the direction of the inequality. This one's greater than a -3. This one was less than a -2, right? But I mean, it's still a negative number. So the real difference here is that this is less than a negative number. This is greater than a negative number. Okay? And is this possible? Go ahead and think about that for a minute. Is this possible? Well, the answer is yes, it is possible, right? Because like we said earlier, the absolute value of any number is going to give me a positive number. So I'm going to end up with some positive x once I take the absolute value of it. And then this is always going to be greater than a -3. Any positive number is greater than a -3. All right, so the answer here is actually all real numbers. I could take any real number on here, any real number on this number line, and if I take the absolute value of it, it will be greater than a -3. If I take a negative number, well, then I take the absolute value of the negative number, which is going to give me a positive number, and that positive number is going to be greater than a -3. If I take a positive number, well, I'm going to be left with a positive number after taking the absolute value, and that is also greater than a -3. So clearly, any number on the number line will work. It will be greater than a negative 3. Even 0, which, by the way, we haven't talked about. But what happens if you have the absolute value of 0? Well, the answer is simply 0. You might have guessed that. So the absolute value of 0 is 0. If I plug in that 0 for x here, well, then the absolute value of 0, is that greater than a negative 3? Well, the absolute value of 0 is 0. Is 0 greater than a negative 3? Yes, it is. We don't often think of 0 as being greater than a number, but because this is a negative number, sure, 0 is certainly greater than a negative 3. Okay? All right. Ponder upon that a little bit. All right, let's move on. This problem. Now what we're going to be doing is making things just a little bit more complex. We're actually going to be solving these inequalities here. All right, so here we have a negative absolute value of x is greater than or equal to a negative 4. And what we really want to do is get that absolute value all by itself. And it's not here. It has the negative sign out in front. So just like when we work with equations, if I have something that looks like this, negative x is equal to a negative 3, what do we do to get rid of the negative? We divide it by a negative 1, right? Divide both sides by a negative 1. That'll create a positive, and this will actually turn into a positive 3. Okay? Same thing applies here, only now it's an inequality, which remember, with inequalities, we treat them, when solving for them, very similarly to equations. All right? The same rules apply, except there is one very important rule, and that is if you ever divide or multiply by a negative number, you have to switch the sign of the inequality. Okay, very important. Don't forget that. Okay, so here we want to get this absolute value of x by itself. So to do that, we will divide both sides by a negative 1, just like we did in this example. Only the thing we need to remember is because this is an inequality, that sign needs to switch because we divided it by a negative number. So that's going to become less than or equal to. All right. And then if we divide these out, we're going to end up with a positive absolute value of x. And negative 4 divided by a negative 1 is going to be a positive 4. All right. So now we're kind of back to where we started in the previous problems. So how could we then graph this? Okay. And we can graph it again by thinking of it in terms of we're looking for x values such that they are less than or equal to 4 units away from 0. All right, so where's 4 units away from 0? Well, here's 0. 4 units away from 0 on this side would be here. Since we could be equal to 4 units, it's going to be a solid circle. 4 units away from 0 on the right would put us here, another solid circle. All right, and what do we want? We want the x's that are less than or equal to 4 units away from 0. All right, so you have to really think about this. If it's less than 4 units away from 0, then we have this segment right here, right? If I put a dot here, this would be less than 4 units away from 0. It'd be 3 units away from 0. If I put it here, it's 2 units away from 0. So again, that's less than 4. So we're going this direction. So all the way to here, these would be acceptable solutions on the negative side. On the positive side, again, we're looking for things that are less than 4 units away from 0. So this would be, this 3 would be 3 units away from 0, and 2 units away, and 1 unit away. Those are all less than 4. So we can use all of these numbers in here as well. And so we end up with this number line, which expresses all the solutions for this inequality. All right? Very good. So why don't you pause the video? Try this one on your own first, and then we'll do it together. This kind of sums up the worst case scenario. This is kind of as complicated as they're going to throw at you. So if you can do this problem, you should have no issues with your seat work. So pause the video, try this one on your own, and then we'll do it together. All right, so let's see how you did. Again, we're going to treat this inequality as an equation in a manner of speaking. We're going to use the same rules except for that multiplication and division of a negative. rule. Otherwise, everything's going to be the same. So we'll start by trying to get this absolute value of x by itself. And to do that, we're going to add 3 to this side and add 3 to this side. That's a good place to start. These will eliminate, and we're left with negative absolute value of x. Now, this sign is not going to change because I didn't multiply or divide by any negative number, so it's going to stay the same. This is a negative 6 plus 3 is going to be a negative 3. Now I can divide out that negative and recognize that, you know, a little alarm bell should go off. Uh-oh, we're dividing by a negative. We're dividing by a negative. So we know that this absolute value, or I mean, this inequality sign has to reverse. It's going to go the other direction. Okay. And then this negative crosses out the negative. You have the absolute value of x. And negative 3 divided by negative 1 is just going to be a 3. All right. And then we have to graph it. So we'll pull up our number line here. And we're looking for numbers that are less than 3 units away from 0. So let's find it where they are 3 units away from 0. That'd be the negative 3, but it can't be equal to 3 units away. So it can't be equal to the negative 3, so we have a hollow circle. On the other side of the 0, it could be the 3, but again, hollow circle. It has to be less than 3. Okay? Where is this going to fall? So we want all the numbers that are less than 3 units away from 0. So again, we're kind of working this direction, less than. And then, you know, from this side over this direction, less than. And we end up getting this line that spreads from negative 3 to 3, but not including negative 3 and 3. All right, so there we go. There is our graph for it. So hopefully you got that right. If you didn't, make sure that you understand what you did wrong so that you don't get it wrong in your seat work. But I think that's about as far as we need to go. So we will stop here, and I will talk to you tomorrow.